Okay, can we start? Okay, what is the answer of this question we were discussing? Yeah, what is the answer of this question, Purvik? Why it is A? Why it is A? Tell me. See, when you write down the expression for Kp for this reaction, that will be the partial pressure of CO2. And Kp value is given, which is 0.0095. Okay, right. So partial pressure would be this. Now, it is saying that 1% CO2 in air is sufficient to prevent any loss in weight when M2CO3 is heated, right? So, 1% CO2 in air. So, what is the partial pressure of CO2 in air? That will be equals to the pressure of 1 by 100 into the total pressure of air. That will be 0.01 into P, right? Or we can say 0.01 atmospheric, 1 atmospheric pressure if you take, right? So now the question is 1% of CO2 is sufficient to prevent any loss in weight when M2CO3 is heated, right? Kp for this is given. Question is how much would be partial pressure of CO2 have to be to promote this reaction at 120 degrees Celsius. Okay, so you see the partial pressure of CO2 for this reaction we are calculating, which is 0.0095, which is almost equals to 0.01. Okay, so if the pressure in air and pressure of CO2 from this reaction is almost same, then the reaction will not proceed, then nothing will happen in this reaction, right? But the question is how much would be the partial pressure of CO2 have to be to promote this reaction, means what should be the partial pressure of CO2 so that the reaction will go in forward direction. So for that process what happens, since the air also has this much atmospheric pressure, almost this much, so the partial pressure of CO2 that we get from this reaction must be less than 0.0095, then only the reaction will proceed in forward direction. So option A is correct here. Got it? Question number 9. Oh, this is again, I'll repeat. See what I said, the reaction that you have from that reaction, according to the Kp value, the partial pressure of CO2 that we get here is 0.0095. And the partial pressure of carbon dioxide in air, according to the question, it is again 1%, right? So 1% of the pressure, right? So 1 by 100 into pressure of air, which is 1 atmospheric pressure. So the partial pressure of CO2 in air will be 0.01 atmospheric. So this 0.01 atmospheric is almost equals to the partial pressure of CO2 that we get from the reaction which is given in the question. Okay, so that is why since the partial pressure is almost same, so the reaction will not go in forward direction. Now to proceed the reaction in forward direction, the partial pressure of CO2 must be less than this value, then only it will go in forward direction. That's why option A is correct. Okay, so this one is the simplest one. Option D is correct. 10th and 11th. Simple one again. Kp is equals to kcrt to the power del n. Option D is correct here. What about the 11th one? Is it Kp greater than Kc? Because since del Ng is greater than 0, so Kp is greater than Kc. 12 and 13. All these are the question based on Kp and Kc relation. Tell me quickly. 12th one is A, correct. 13th, are you getting B? It's not same. You see here it's Kc by Kp, and here we have Kb by Kc. So option A is correct, not B. What? That is how you make mistakes in the exam also. Yesterday also I was discussing this. Read out the question properly. See it properly. Like what is the question? Correct? So -1 again. This question you should get +4, right? You actually have lost 5 marks. That's why I'm saying don't make these kind of mistakes. Okay, read out the question properly. Don't assume the question like, okay, this is the question should be this. See it properly. So Kc by Kp is option D. Next one. 14. Equilibrium constant depends only on temperature. So it remains same. What? Saimir and Ritvik and Purvik, what are you doing? Kc depends only on temperature, right? So whatever you change the temperature, the concentration, that won't affect the equilibrium constant. It would be same. These are the few key points you should keep in mind. Don't uh, do these kind of mistakes. Question number 15. Is it B? Purvik is getting B. We have to add the three equation, right? And once we add, the equilibrium constant will get multiplied. Fine. So when you add all these three, the equilibrium constant will get this equation, and for this the k will be equals to k1 into k2 into k3. So option B is correct. All of you are getting A. 16 is A. It's correct. All of you are getting, so I am not solving this. Okay, 17. What about 17th? All of you are getting C. C is correct. If you want me to solve, let me know. Done? All of you? Sam here, what happened? I think he's not there. Anyways, 18th and 19th. 'Ionic equilibrium. Okay, I'll give you some questions on ionic also. Solve these two. 18th A is correct. 19th you solve. Then I'll give you some question of ionic equilibrium. 19th, again you are getting A. This is also correct. So 18th A is right. 19th A is again right. You want to solve some question of ionic equilibrium? Want ionic equilibrium? I'll give you that question only then. Yes. Tell me yes or no. Okay, so you see this question. I'm giving you this question because I don't have the picture of this. You have to find out the pH of 10 to the power minus 4 molar OH minus solution at 330 Kelvin if Kw is given at this temperature, and that will be equals to 10 to the power minus 13.6. Tell me the value of pH. There are two options, 9 and 9.6. There are two options I'm giving you, 9 and 9.6. Other two are 4 and 10. Tell me an answer. 9.6 exactly you are getting, right? We know this Kw is equals to what? Concentration of H plus into OH minus. OH minus concentration is given, so H plus concentration will be 10 to the power minus 9.6. So pH will be 9.6. Okay. Next one you see. What would be the pH of a solution obtaining by mixing? We have to find out pH, right? I'll just give you the question in short. pH we have to find out, and we have a mixture of 5 gram of acetic acid plus 7.5 gram of sodium acetate, and the volume is equals to 500 ml. Ka is given 1.75 into 10 to the power minus 5, and pKa is 4.76. Solve this. 4.80. 4.80 is exactly correct. See, the concentration of CS3COH, the acid, 5 divided by molar mass of this is what? 60 into 1000 by 500. So that will be 0.166. Concentration of salt, if you calculate, this will be 7.5 is the mass given, and for this the mass is 82 molar mass, 1000 by 500. It is 0.183. Okay. Now this mixture gives you an acidic buffer, right? Acidic buffer. So pH for acidic buffer will be what? pKa plus log of concentration of salt divided by concentration of acid. Okay. pH is 4.76 plus you will get some value over here. The point is what? Here when you solve this you'll get log of 1.1 approximately. Okay. Now when you see the option, like the option is given pH is 4.70, option A. Option B, pH is less than 4.70. Option C, pH of the solution will be equals to the pH of the acetic acid, and D is 4.76 to 5, like this. Okay, so you see if you are getting log greater than 1 over here, right, greater than 0 actually, then this value will be what? Greater than 4.76. Hence the option will be, answer will be this. If you exactly solve this, your answer will get 4.80. Okay, so like this, if log value is not given, according to the option you can choose whether it is less than pKa value or more than pKa value, any option, right? So this is the answer we have here. Understood? Correct. Can we move on? Next one you see. You have to find out again pH of a buffer solution. It is mentioned of a buffer solution prepared by dissolving 30 gram of Na2CO3 and for this we have 500 ml plus we have aqueous solution of this, 500 ml of aqueous solution of this, and it is dissolved into 1 molar HCl, 150 ml. pH you have to find out for this. Ka is given for HCO3 minus 5.63 into 10 to the power minus 11. What happened? Option you want? Options are 10.197. If you need any log value, you can refer log table or calculated anything if you have. 9.858, and the last one is 6.400. What happened? Purvik. Na2CO3 plus HCl forms NaCl plus NaHCO3. What is the molecular mass of this? Okay. What is the molecular mass of this? 106, right? So number of moles for this will be what? 30 divided by 106 is the number of moles. And for this, the number of moles will be what? It is given 1 molarity. So 1 into 150 is the number of millimoles actually. And here, the number of millimoles, if you calculate for this, so that will be 30 into 1000 divided by 106. And when you solve this, you'll get 283. .98 you are getting. Not right. Okay. So you see here we have 283 millimoles and 150 millimoles, right? So when the reaction proceeds, what is the millimoles of this left? 283 minus 150, which is 133 of this salt will left. This will be 0. This forms 150 millimoles of this and 150 millimoles of this. The solution containing Na2CO3, 133 mole of Na2CO3 and HCO3 minus. So this acts as an acid buffer. So pH formula will be pKa plus log of salt. Salt is what? CO3 2 minus. By acid is excuse me, NaHSO3 or HCO3 2 minus. All these value you have to substitute. pH is nothing but minus log of Ka plus log of CO3 2 minus is 133 divided by 150. So this is what you have to solve. And when you substitute all the value, you will get 10.197 approximately. 10.197. Yes, 133. 133 by 150, because 150 millimoles of this NaHCO3 is forming. And what is the salt left? The salt left is this 133. So log of concentration of salt by acid. Understood? Can we proceed? Tell me fast. Two more questions we'll discuss. Okay. The last two questions. Write down solid BaNO3 whole twice is gradually dissolved in 10 to the power minus 4 molar Na2CO3 solution, at which concentration at which concentration of Ba plus 2 precipitate of BaCO3 begins to form KSP for BaCO3 is given, and that is 5.1 into 10 to the power minus 9. What is the answer? You want options? 5 point excuse me, 5.1 into 10 to the power minus 5, 7.1 into 10 to the power minus 5, 4.1 into 10 to the power minus 5, 8.1 into 10 to the power minus 7 minus 2. You are getting A 5.1, it's correct. What is the condition for precipitation? The concentration, the product of Ba plus 2 and CO3 minus 2 should be greater or equal to its KSP value. Then only the precipitation takes place. Right? So Ba2 plus concentration we have to find out. So that will be what? KSP 5.1 into 10 to the minus 5 minus 9 divided by 10 to the power minus 4. So it will be 5.1 10 to the power minus 5. Option A is correct. Right? This is the condition. Now the last question for today. An acid is given Ha ionizes as H plus A minus. pH of 1 molar solution is 5. Find its dissociation constant. Cornelia is getting 10 to the power minus 10. Nothing is given here. So we assume the initial concentration is 1, 0, 0. Right? pH is given. So we have the H plus concentration which is 10 to the power minus 5. And since 1 mole ratio we have, so the concentration of H plus would be equals to the concentration of A minus. And how do we get this? When this acid will dissociate. So when this 1 moles gives 1, to get 10 to the power minus 5 moles, 10 to the power 5 moles of this must dissociate. So 1 minus 10 to the power minus 5. This is the equilibrium concentration of this. So we can write down the Ka for this acid is equals to H plus into A minus 10 to the power minus 5 into 10 to the power minus 5 divided by 1 minus 10 to the power minus 5. So since 1 is far greater than 10 to the power minus 5, so we can neglect 10 to the power minus 5 with respect to 1. This is equals to 1, and hence K is equals to 10 to the power minus 10 approximately. How did you get 10 to the power minus 3? What did you do? Saim here, Ramcharan. Don't do all these kind of mistake. Okay, you're not losing one marks, but you're losing 5 marks. Okay, so whenever you get some easy questions, take your time and solve it. Read the question properly. Okay, and one more thing, you're not going to solve all the questions. Okay, so opt the question and then read it properly and then solve. Don't make all these silly mistakes. These are the easy questions. Okay, don't lose marks in these kind of questions. Anyways, so we'll wind up the class here only, and next week probably, I don't know, next week probably you will have class. Okay, this week you don't have any chemistry class now. Tomorrow you don't have any chemistry class. Okay, so wherever you feel like you have less confidence or something, you just revise those topics. Okay, I have sent you yesterday the um, the boron family questions, right? Assignment I have sent you yesterday. Okay, so today also I'll send you carbon and other groups questions. Okay, those you must go through. Okay, chalo, bye bye, see you soon.